Let's see how we can add displacement to enhance the look of our materials. Displacement is a technique that uses a texture map to move the points of the actual geometry and create a sense of depth and detail. A displacement map is a grayscale texture where all the gray values represent how Thea should displace the mesh. Black means no displacement and white 100%. In Thea for SketchUp, displacement can be found in the Material tab of the Thea tool panel and is only available when editing in the full editor. Displacement can be enabled by ticking the checkbox. To see the surface displaced, we need to load the displacement map first. Usually textures come with a height map that can be used for displacement. Let's have a look at the rest of the parameters and see how each one affects the overall look and quality of the displaced surface. Subdivision affects the original geometry by subdividing faces on render time. In the following example, we have a surface divided in SketchUp into smaller and smaller squares. Each square, regardless of its physical size, will be subdivided by Thea same number of times as displayed in a parenthesis. It means that the denser the geometry is in SketchUp, the better the same displaced material will look. Here is how the displaced surface looks, going from large to smaller faces. The height value controls the maximum surface displacement in conjunction with the height map. Based on what we said earlier, a white color will displace the surface using the defined height value. In this case, white displaces the surface by 2 cm. The center option will offset the displaced surface based on the defined value. Let's try to understand this with a simple example. We have a simple surface using a displacement map that has white, middle gray, and black. We also have a surface that will be used as reference for zero height. When the center value is set to 0, black will cause no displacement to the surface. A value of 0.5 will make the middle gray value to have no displacement. And finally, a value of 1 will invert displacement, making the white color to have no displacement. This option can be useful when the displaced geometry intersects with other objects in the scene, like a carpet for example. Neuron Smoothing should be turned off when the original surface has sharp edges. In any other case, it is best to have this option enabled. Tight bounce helps to render faster, but initialization will last longer. In this example, you can see the huge impact that tight bounce has over render time. The only situation where you might need to turn it off is when you run out of memory, since this is a memory-intensive process. Topology and texture mapping of the original geometry are both important for the quality of the displaced surface. As you can see here, we have subdivided the original geometry with a huge impact on the quality of the displacement. Thank you for watching.